All right, let's talk about the Pythagorean Theorem. Okay, so the Pythagorean Theorem is a formula we use with right triangles. It only works in right triangles, and what it says is that a squared plus b squared equals c squared. A and b are the lengths of the legs of the right triangle, and c is always the hypotenuse. So remember, the hypotenuse is always that longest side across from the right angle, and then the legs are the other two sides of the right triangle, the two that are attached to the right angle. Okay, so again, I like to think of it this way because a lot of times students get the numbers in the wrong order. It's the leg squared plus the leg squared equals the hypotenuse squared. So here's a simple example. It wants us to find the length of the missing side. Leave your answer in simplest radical form. Okay, so we have a right triangle here. We have two of the three sides, and anytime you have two of the three sides of a right triangle, you can use the Pythagorean theorem to find that missing side. So we write down the Pythagorean theorem, and then we fill in the values we have. And again, be very careful as to what you have. So take a look at your triangle. I'm just going to label it real quick. So here's my right angle, which means this is my hypotenuse across from that right angle, and my legs again are the two sides attached to the right angle. So here's a leg and here's a leg. So my legs are 8 and 6. So a squared, 8 squared, plus 6 squared equals c squared. C would be my hypotenuse. I'm going to square each of those. Now remember, squaring means to take a number times itself. So this would be 8 times 8 is 64. 6 times 6 is 36, and that's equal to c squared. Now we add our two values that we know together. 64 plus 36 is 100. And here we're to the final step. We want to solve for c, and right now it's squared. To remove a squared, you do the opposite, which is to take the square root. This is called a radical. Okay, this square root symbol is called a radical. So when they say leave it in simplest radical form, if this square root is not a whole number, we want to leave it in radical form. So let's check. What's the square root of 100? It is 10. So we didn't have a radical left because we were able to take the full square root, and we just get that c is 10. Okay, find the length of the missing side. Leave your answer in simplest radical form. So once again, we notice we have a right triangle. We know two of the three sides. So we write down the Pythagorean theorem that a squared plus b squared equals c squared. Make sure you know which parts you have. So again, across from a right angle is the hypotenuse, that longest side. So that would make this a leg and this a leg. So this time, notice we know one of the legs in the hypotenuse, and we're missing one of the other legs. Okay, so we fill in our information. We know one of the legs is 4. We don't know the other leg, so I'm just going to call it b. And then we know our hypotenuse was 5. That's hypotenuse is always the c. Square the things we can. So 4 squared is 4 times 4 is 16. Plus b squared equals 5 times 5 is 25. This is going to work out differently because notice the variable I'm solving for has things with it. So first we need to move this 16 to the other side. It's positive 16, so if we subtract 16 from both sides, we get b squared equals 9. We need to get rid of that squared, and again, to get rid of a squared, you do the opposite, which is to take the square root. The square root of 9 is 3. Okay, here we have another. Find the value of x in simplest radical form. We start the same way. We say, oh, I've got a right triangle. I know two of the three sides, so I can use the Pythagorean theorem to find that third side. I write it down. A squared plus b squared equals c squared. What parts do I have? Again, across from the right angle is your hypotenuse. So x is my hypotenuse. The other two would be my legs. So that means this would be a leg, and this would be a leg, the ones attached to that right angle. We fill in our information, so our legs are 4 and 8, and our hypotenuse is x. We go ahead and square. 4 squared, 4 times 4 is 16. 8 squared, 8 times 8 is 64, equals x squared. We add our two values here since they're on the same side. 16 plus 64 is 80. We're down to 80 equals x squared. Get rid of the squared, we take the square root of both sides. And we get x equals, now notice if you put that into your calculator to find the square root, we don't get a whole number, we get 8.944279191. Now this is where the leave your answer in simplest radical form comes in. If they say that, they do not want this decimal answer. Okay? What they want you to do is go back to x equals the square root of 80. And they want us to simplify that if we can at all. So what they mean by simplifying this and putting it in simplest radical form is if we can factor this down and there's any perfect squares that will go into this, that's what they want us to do. Okay? So looking at 80, okay, so perfect squares are squares that, okay, so our numbers like 4 is a perfect square because the square root of 4 is a whole number 2. The next one would be 9. And so this is what you're looking for when you're trying to simplify and put it in simplest radical form, is a number that's a perfect square that would divide evenly into it. So 4, the square root is 2, 9, the square root is 3. What has a square root of 4? 16. 25 has a square root of 5. 36 has a square root of 6. 49 has a square root of 7. 64 has a square root of 8. 81 has a square root of 9. 100 has a square root of 10. 121 has a square root of 11, and 144 has a square root of 12. It would be good for you to have these in your notes or have them memorized. These are the perfect squares up through 12, okay? And when you're simplifying a radical, that's what we're looking for, is we want to, if we can, break 80 down at all, if at all possible. So, do any of these numbers divide evenly into 80? Is what our question is going to be. Okay, well, immediately I can see, I know that 80 is 4 times 20, and 4 was one of my perfect squares. So if that's the only one I can see, I'm going to go with that one first. Okay, so what we're doing is we're breaking this down. 80 is the same as 4 times 20. And 4 has a whole number square root. We can take its square root. So then we separate those into the one that has a square root and the one that does not have a whole number square root. That gives me the square root of 4 times the square root of 20. Now I can take the square root of 4, it's 2, okay, and then it gets to come out of the radical, but the 20 would have to stay. And then I want to reevaluate my answer. Okay, so now I have the answer x is equal to 2 times the square root of 20. Am I simplified as far as I can, or can I break 20 down again? Okay, did I miss something beforehand and a bigger number went into it? And if you look at 20, notice 20 is, again, 4 goes into 20, and 4 is one of my perfect squares. Okay, so I can break this down again. Again, it's 4 times 5. I'm going to separate those into the one that has a whole number square root and the one that does not. The square root of 4 is 2, so I have 2 times 2. Square root of 5 equals x, and finally 2 times 2 is 4. So my answer in simplest radical form is 4 times the square root of 5. Okay, 5 cannot break down any further and have one of these perfect squares go into it. Okay, so you're going, oh, that's a lot of work. Well, if I had seen beforehand, I just wanted to show you if you don't get the biggest number first, you can still keep going. and evaluate when you get to the end and go, okay, do I have absolutely everything out of there that I can take? Um, one thing that would have made this shorter is if I had noticed that 80 is also 16 times 5, because 16 is one of our perfect squares that has a whole number square root. And then I could separate those, and the square root of 16 is 4. The square root of 5 has to stay because it doesn't have a whole number square root. So that would have been a faster route. But if you go small and work your way up until you have everything out you can get out, that method works also. So when they say leave in simplest radical form, that happens anytime you can't find the square, it's not a whole number. You break it down as much as you can using these perfect squares. All right, let's try this example. All right, here's another example that's a little more challenging because we have x in more than one place. We still set it up the same way. We have a right triangle, and we know that for right triangles we can use the Pythagorean theorem. We want to keep in mind that a and b again are the legs and c is the hypotenuse. So in this case our legs are x and 9, so I have x squared plus 9 squared equals, and my hypotenuse is x plus 5. We want to square everything, so x squared, really all we can do is write x squared. 9 squared, 9 times 9 is 81, and then over on this side, one thing we have to remember is that squared means to take a number times itself. So x plus 5 squared means x plus 5 times x plus 5. At this point, we need to remember from algebra something that was called FOIL, where it told you what to do when you had two numbers in two terms in parentheses times another two terms. And that was to FOIL, which means we take the x times everything in this set of parentheses, and we take the 5 times everything in this set. The F sounds for first, the first times the first. Okay, so x times x is x squared. Then we take the x times the 5, that's our outsides, our O. X times 5 is 5x. Next, we've done x times everything, so then we move to the 5 and take 8 times everything. 5 times x is 5x, that's our I, or our insides. And finally, 5 times 5 is 25, that's our L, the lasts. So I have x squared plus 81 equals x squared plus 5x plus 25. I'm going to simplify that a little bit. I have 5x and a 5x. Since they're both just x's, I can add them together to get 10x. Alright, at this point, we need to gather x squareds with x squareds. So here I have an x squared. If I subtract x squared, that would remove it. I have to do the same on the other side. Whatever you do on one side, you have to do the other. And notice it cancels on that side also. So in this case, my x squareds are gone. And I have 81 equals 10x plus 25. We need to solve for x. So we need to move this 25 to the other side. It's a positive 25. So if I subtract 25 from both sides, I get 56. 10x equals 56. Divide by 10. And I get that x is 5.6.